On Friday, we talked about the first way that we're going to discuss to solve quadratic equations. What was that? Graphing, right? How did we solve quadratics by graphing? We could have put it in the calculator, yes, but putting it in the calculator just shows us what the graph looks like, right? Does that actually solve it for us? Does that actually tell us the answer? No. What were we looking for on the calculator? X-intercept, right? We wrote it on the front of our page. The points that we care about are located on the x-intercept, on the x-axis, called the x-intercepts. Okay? Where those x-intercepts were are the solutions to that quadratic equation, right? Today, we're going to talk about the second way to solve quadratics. There's several different ways to solve it. We're going to focus on three, okay? The first way was by graphing. Can you figure out what the second way is? Oh my gosh, factoring, that's right. Good job. Sorry, that was a little sarcastic. I'll take it back. Just a little bit of it, though. Okay? Thank you. There are 4 steps that we're going to follow today. Okay? For the record, my goal is no homework. My goal is to get all the way through these 3 sample problems and get all the way through the 4 homework problems back here before the bell rings. That's my goal. Are you with me? Okay. There are 4 steps we're going to follow when we are solving by factoring. Okay? The first step is to set the equation equal to 0. The second step is to factor. The third step is to set each factor equal to 0 and solve it. And the fourth is to check it, either with a graph or by another way I'm going to show you when we get there. Okay? You're fine on 1, you're fine on 3, you're fine on 4. 2 is where you've struggled in the past. The factoring part. Okay? So I'm going to go through these problems and just remind you how to factor. Okay? So we're starting right here on sample A. Okay? First step, set each equation equal to 0. What do I have to do to this equation to get it equal to 0? Yes? Yes, absolutely. Subtract 6 from both sides. When I subtract 6 from both sides, that now is 0, isn't it? And I have x squared minus x minus 6 equals 0. Okay? So now is the equation equal to 0? Is my first step complete? Yes. Now I have to do step number 2, which is factor. So the first thing that we recognize, hopefully, is that we have a trinomial. Do you recognize that? Is that a trinomial? Yes. The second thing we recognize is, what is the leading coefficient? A 1. When the leading coefficient of a trinomial is 1, we factor things a certain way. We say, what 2 numbers multiply to be negative 6 and add to be negative 1? Can you tell me what 2 numbers those are? Multiplies to be negative 6 and adds to be negative 1. Positive 2 and negative 3. That's absolutely right. Because we have a trinomial with a leading coefficient of 1, we can go straight to our factors. And you told me the 2 factors were what? Positive 2 and negative 3. So I have now factored my trinomial, right? So that's step number 2. I'm done. Step number 3, set each factor equal to 0 and solve. That means this is a factor, right? The x plus 2. I say x plus 2 and set it equal to 0. This is a factor, right? The x minus 3. I set it equal to 0. Now I have 2 completely separate equations that I solve. I subtract 2 from each side and get x equals negative 2. I add 3 to each side and get x equals 3. Is step 3 complete? Did I set each factor equal to 0 and solve? Yes. Check solutions by graphing the representative function and comparing zeros of the function. Okay, what? What does it want me to do? Graph it, right? It wants me to graph it in the calculator, which you all got when you came in, right? You guys are full of crap. X squared minus x minus 6. I'll show you in a minute. Or he can show you. Here's my graph. Look at my answers. X equals -2 and x equals 3. What is true about those answers and my graph? Those are the x-intercepts. It crosses the x-axis at -2 and it crosses the x-axis at +3. That is checking my work. Is that the only way to check my work? No. Now, that's what number 4 says, but I want you to be aware that there's another way. How do we normally check our work when we solve for x? Can't we just substitute it back into the very beginning? Yeah. What's -2 squared? +4. 4 minus a -2. 4 minus a -2 is 6. Look, 4 minus a -2. Right? That's 6. Does 6 equal 6? Then that is the right answer. Does that mean that one's wrong? If I know this one was right, is this one wrong? How do you know that? If you'll remember from Friday, on this worksheet, we talked about the fundamental theorem of algebra. The fundamental theorem of algebra says that if it has a degree n, I have n complex roots. What's the degree of a quadratic? 2. How many roots should it have? 2. One of my roots is -2. So is that it? Is that all of my answer? No, it's a quadratic. Look at the degree, the highest exponent. That means I should have another answer. But is it 3? What's 3 squared? What's 9 minus 3? Does 6 equal 6? Then that is my other answer. Does that make sense? Okay. So A is finished. It's completely done. Any questions on A? Okay. Then let's look at B. Step 1. What's step 1? Equal 0. Get it equal to 0. I want to subtract 5 from both sides, and I want to add 9x to both sides. Okay, so why didn't I just subtract 2x squared from both sides? Wouldn't that have been easier? Right now it would have. Later, it would have made the problem harder. If I have a choice, I want to keep my x squared term positive. My a value, I want to keep it positive. Okay? So 5 minus 5 is 0. Negative 9x plus 9x is 0. So I end up with 2x squared plus 9x minus 5 equals 0. Why did I write it in that order? X squared comes first, then my x term, then my constant, right? Anyone? Besides the person who answered it? Okay, good. Are we good so far? So have we completed step 1? Okay, what's step 2? Factor. Is this one as easy to factor as number 1? No, but is it difficult? No. Here is where we have to do AC. You remember that? What's AC? What is A times C? Negative 10, because it's 2 times negative 5, right? What's B? 9. So I have to think, what two numbers multiply to be negative 10 and add to be 9? One and 10 multiply to be 10. 2 and 5 multiply to be 10, but I've got to multiply to be negative 10 and add to be 9. What do you think it is? Negative 1 and 10. Those are the two numbers I need to use, right? Negative 1 and 10. But because my leading coefficient is not 1, I cannot go straight to my factors like I did up here. Okay? This is where we have to rewrite the problem. Do you remember that part? I rewrite the problem. I make this middle term into two different parts. These two parts that you just told me. 2x squared minus 1x plus 10x minus 5 equals 0. Does everybody see that I have not changed the problem, but just rewritten it? We okay with that? Could you do it by yourself if I asked you to? Okay, we'll get there. Fair enough? Okay. As long as you can see how my work is done, there's steps we can take to get there for you to do it yourself. Okay? That's one of the places I'm struggling on. Honestly, that's where I'm struggling on in my master's class right now, the class I'm taking. Because, like my friend Stephanie, she can do the problem and show me, and I can totally understand every single step of it, but I have no idea where it came from. Like, I don't think I could do it by myself. And so she sits and explains to me every step, how every step came to be, where it all came from, and then I understand it, and then I can do it by myself. You see what I'm saying? So as long as you can see where it came from, I can always go back and explain every step so you can be able to do it by yourself. Fair enough? Okay? So now that I have 4 terms, do you remember what to do to factor it? Just look at the first 2. Yeah. What's common in the first 2? An x. What's left if I divide each term by x? 2x minus 1. Perfect. Now just look at the second 2 terms. What are they both divisible by? A 5. When I divide each term by 5, what's left? 2x minus 1. Are the parentheses the same? Then I can go to the last step. What's the last step? What did I factor out? Factor? What? That's not even a word. What did I factor out of each term? An x and a 5. What did they have in common? 2x minus 1. That is factored. So that ends step number 2. Okay? How are we feeling about this factoring stuff? Is it still the F word? Yeah? That's okay. We can work. We can work. Not that I would ever say the F word. Now what? Step 2 is done, so we got to go to step 3, right? What's step 3? Set them to 0. X plus 5 equals 0. 2x minus 1 equals 0. Okay, so this crazy kid earlier was like, okay, Miss Kingston, why can't we just take the opposite, right? That's a positive 2 right there, and that's a negative 2. That's a negative 3 right there, that's a positive 3. Can we just take the opposite? And I said, that's a good question. And sometimes you can, but it doesn't work every time. Because see, look, this is x plus 5, right? Just take the opposite. Oh, that works. Right? Oh, this is a negative 1. It should just be a positive 1, right? Right? If I add 1 to both sides, I get 2x equals 1, and then I have to divide by 2, giving me a half. So do you see how it works sometimes, but not all the time? So be super careful about that. That's not a shortcut. Okay? That's not a shortcut that works every time. So be super careful. That's why the directions up here, the steps that they want you to do, is set each factor equal to 0 and solve. They didn't just say, just take the opposite, did they? Okay? Questions? So, I mean, I put a square around them already. Does that mean they're automatically right? Or should we check them? We should check them, okay. So, how are we going to check them? How did we do it? We could either plug it in or we could graph it, right? Anybody have it done in the calculator yet? Let me see your calculator. Don't throw it. I can't reach that. Yeah, it's clearly Shad's fault. It's blank. That's what's in your calculator right now. Nothing. 2x squared plus 9x minus 5. What am I looking for? It doesn't do me any good to know that I have to check with the calculator if I don't know what I'm looking for. What am I looking for? Does it cross at negative 5? Yes. Does it cross at a half? Yes. Then are these right? Yes. Good. Oh my gosh. Okay, last one. You ready for C? Yikes, yikes. Ready for C? What do we do first? Set it equal to 0. How am I going to get this equal to 0? How am I going to get this equal to 0? Subtract 16 from both sides. Anything else? Add 8x to both sides. 2x squared. Oh, look, I can combine those two terms, can't I? The negative 4x and the 8x to get 4x minus 16 equals 0. Okay, so do you want to do this the hard way or the easy way? I want you to be able to tell me which way is the hard way and which way is the easy way. Step number 2 is factor, right? What's the very first thing we're supposed to do when we factor? Very, very, very first when I factor. It starts with a G. And then C. Greatest common factor, right? That's the easy way. Some of you were saying do the AC. You want to do the AC, we can totally get the right answer, but it's more difficult, it's longer, and it's bigger numbers. What is my greatest common factor here? A 2. What's left if I divide a 2 out of each term on the left-hand side of the equation? Perfect. X squared plus 2x minus 8, correct? What do I do with the 2? Oh, I don't want to, because I don't want to distribute. That would give me exactly what I had at the beginning, right? Good guess, though. Good guess. Right now, I just want to ignore it, okay? And I want to factor this. But look at the good news. What's the leading coefficient here? 1. So I can say what multiplies to be the last term and adds to be the middle term. What kind? Negative 2 and positive 4. Because my leading coefficient is 1, where can I go straight to? I can go straight to the factors, can't I? What'd you say it was? X plus 4 and x minus 2? Now it's all the way factored, isn't it? Okay. Look at step number 3. Step number 3 on this problem can be tricky if you let it. Don't let it. This says to set every factor equal to 0. Is x minus 2 a factor? Yes or no? Yes. Set it equal to 0. Is x plus 4 a factor? Set it equal to 0. Is 2 a factor? Is 2 something you multiply together to get that original equation? Yeah, set it equal to 0. But guys, on what planet does 2 equal 0? Not mine. Not mine, right? I don't have to worry about it. I don't know if a 2 equals 0 on any other alien planets. I've never been there. Yet. You better shut up. Does 2 equal 0? No, then we ignore it. Okay? Here I add 2 to both sides. X equals 2. Here I subtract 4 from both sides. X equals negative 4. And thanks to our handy dandy graph, brought to you by Hunter Weir, who also did the last one, but whatever. X equals 2. It crosses the graph crosses the axis at 2, the x-axis. X equals negative 4. The graph crosses the x-axis at negative 4. Yes? So I know that these are my 2 answers. Any questions?
Why do we have to do it on paper when we just do it in the calculator?
Because there might be directions that say solve by factoring, and you have to do it by factoring or you get it wrong. In the real world, are they going to say, here's a real world situation, you have to factor? No. Okay? But sometimes learning how to do some kinds of math builds brain pathways, like neural pathways in your brain, and that's good for you. Mr. Fuqua brought me an article a couple years ago, and I wish I could find it. I may have to ask him if he can bring me another one. But it said that learning different kinds of math, playing math type games like Sudoku or Kokoro, things like that, builds different neural pathways in your brain. And it's been shown that people who do that more often when they're younger or even when they're middle age are less likely to get Alzheimer's, because that deals with the neural pathways in your brain, and this like counteracts that because you have more neural pathways in your brain. So sometimes I can't give you a good answer why you have to learn it, other than they tell me I have to teach it to you. But here, maybe it'll help you like when you're older. Okay? Like older. Okay? I don't want you to have Alzheimer's either. I'm not guaranteeing that you're not going to get it because I'm teaching how to factor, but hopefully we'll build some more neural pathways in your brain. Okay? Are there any other questions? Any other questions on this stuff? Okay? Then you have the rest of the period to do 5, 6, 7, and 8 on the back. Okay? You have the rest of the period. Shout out to Hayden. See, that's really funny too, because I already have 3 Haydens, so nobody knows which Hayden I'm giving a shout out to. I'm not going to say the brown one. I'll sound racist. Peace.